Breathe in the quiet of the night, where the sky is a slow ocean, and the stars are patient lighthouses, and let a single question expand across your thoughts. How does it all end? When the music of the cosmos fades, when time exhales for the last time, when even light decides not to arrive anymore. From the earliest fireside myths to the equations etched into blackboards, people have listened for the last echo and asked whether the universe ends in a hush, a collapse, or a tear. And already the clues are older than you think. Ancient storytellers kept calendars of catastrophe and renewal, speaking of worlds that burn and worlds reborn, cycles as steady as breath, suggesting a sky that remembers how to return. The Stoics imagined the great ekpyrosis, a cosmic fire that cleanses. The Hindus counted kalpas longer than memory, and Mayan stones circled through ages like clocks that forget to stop. In their shadows, the modern idea of an ending feels colder, quieter, less like thunder, and more like a room where the embers die inch by inch. Centuries later, the age of steam and steel found an omen in the glow of hot iron and the quiet sigh of cooling engines. The second law of thermodynamics had a prophecy hidden inside it. Entropy rises, energy spreads out, and useful differences soften until nothing is left to do but wait. William Thomson spoke of a universal running down. Boltzmann tried to write the statistics of memory into the air itself, and their vision unfolded like frost. A universe drifting toward uniformity with no island left for work. On the largest scales, the story requires a stage big enough for stars to burn their libraries and still leave a trace. General relativity gave that stage, curved and dynamic, a fabric that can stretch, fold, and ripple. Astronomers measured the redshift of galaxies and saw not a static backdrop, but a universe expanding, carrying islands of matter away from one another, like autumn leaves on a wide, slow river. Each leaf convinced it is still while the river lengthens in the night. For a time, it seemed the river might slow as gravity tugged at every drift, perhaps even reverse, as density grew heavy enough to fold the fabric back on itself. The big crunch stood like a final chord, a recapitulation of the opening act, a universe closing the door it had once opened. But the late 20th century held another whisper. Distant supernova blinking weaker than expected, space-time itself accelerating as though an invisible pressure urged it outward, changing the final note before we could hum along. We call it dark energy because the name buys time while understanding is scarce, a placeholder in the equations and a profound silence in our intuition. If this pressure persists, galaxies drift beyond one another's horizons. The night grows lonelier, and the future becomes a ledger of separation rather than return. Yet a change in this pressure might steer the river into a different valley, where an ending can be a fold, a break, or an endless thinning. Three endings haunt modern cosmology: the slow snow of heat death, the decisive recoil of a big crunch, and the dramatic unraveling of a big rip, and each has its own cadence, its own scent of inevitability. The first is a fading, the second a fall, the third a tearing, and with every new measurement, we weigh their likelihood as though predicting the last word of a poem we barely understand. In that poem, the punctuation is a constant whose value we write down and rewrite with trembling hands. Heat death is the entropy prophecy writ large, a universe that does not end with a bang or a shatter, but with a gentle equalization, a final silence when gradients are gone and nothing changes because nothing can. The Big Crunch imagines gravity reclaiming its primacy, turning expansion into contraction, until everything meets everything in a bright, brief sharing of space. The Big Rip is a stranger promise, where the acceleration grows so wild that the fabric fails at all scales, and even atoms cannot hold on to their doubts. The last is exotic, because it demands a kind of energy more negative than the vacuum we think we know. And the middle is nostalgic, because it offers closure, while the first is monotone and nearly infinite in patience. Yet before choosing, we must listen back through the ages, asking what the fossil light suggests, what geometry reveals, and how a young universe's shiver could dictate its final slumber. Here the cosmic microwave background becomes a map of the earliest whisper, and its speckles speak in ancient syllables. That faint bath of microwaves is the oldest photograph we possess. A baby picture of the universe taken when it was only a few 100,000 years old, grainy and delicate, with tiny fluctuations that would grow into continents of stars. From its curves and statistics, we deduce flatness with an almost eerie precision, a geometry that lies close to the knife edge, where expansion neither closes nor wildly bends. Yet the knife edge is not the prophecy itself, only a signpost pointing toward possibilities. Even the flat universe can end in more than one way, depending on what dark energy wants and whether it chooses to remain what it is. If the vacuum energy is truly constant, it locks the future toward an ever-widening drift, a de Sitter hush where horizons seal off conversations forever. If it changes its mood, perhaps it fades and yields to gravity, or perhaps it intensifies and tenses the fabric, neither option announcing itself loudly in the glow we currently see. A more clandestine clue lies not in curvature, but in time itself, in the direction of change that seems so obvious and yet so mysterious. The arrow built of entropy, and the memory we mistake for certainty. Boltzmann suggested universes are statistical flukes, and time is the direction where order becomes rare. But that thought trails into paradoxes with eyes that stare back, daring us to imagine minds blooming in thermal noise. The end of time becomes also the end of reason as we know it, and that is a darkness of a different kind. Even the life of stars, as majestic and assured as sunrise, is a brief chapter. Hundreds of trillions of years blink in a story that does not require us. Red dwarfs will smolder for trillions. White dwarfs will cool. Black holes will breathe radiation away. And the ledger of energy differences will thin to quiet page after quiet page. Somewhere in that ledger lies the story of the last light, the last fusion, the last structure, all depending on what the background pressure decides to be when patience runs out. The cosmic acceleration we measure today is mild, a steady push rather than a shove. But its equation of state hides behind uncertainties and assumptions, and the future magnifies small errors. If the parameter that governs it sits exactly at -1, the vacuum is a constant forever. If it rides slightly above, the pressure will ease. If slightly below, the pressure tightens with time. Within those slivers sit the three endings, waiting for the sixth decimal to choose their throne. We stand in the middle of a room with three doors that appear identical until you look at the hinges, and our instruments grow more precise by the year, even as the hinges refuse to creak. New telescopes survey supernova at greater reaches. New maps of weak lensing trace the scaffolding of dark matter, and radio arrays listen to hydrogen at cosmic dawn. All of them sensing not just what the universe is, but how it breathes. If we can feel that breath, we might predict the sigh, and perhaps hear a hint of the final exhale. The first door opens onto the slow world, the heat-death path, where time becomes thin and distances expand into non-participation. And yet, even in this quiet, physics promises strange finales. With patience as a resource, even rare processes become certain, and fluctuations write strange poems in the dark, some of which may even notice themselves. The slow world is not empty of events. It is a world where events are so far apart that narratives dissolve, and yet curiosity does not, because even silence sometimes trembles. The second door guards a return, a universe that grows like a held breath, and then relinquishes itself back to density, an ending that is also a beginning if the bounce can spare information and avoid absolute singularity. Ancient cyclical myths smile at this possibility, as though recognizing an old friend dressed in new mathematics, and quantum gravity leans forward as if to catch the fall. The question is whether the rules of spacetime can bend without breaking, and whether memory can cross such a threshold intact. The third door hints at disruption, a future where even the relationships that define matter loosen and fail, not because the parts are tired, but because the stage tears apart beneath them. The Big Rip dares to imagine an acceleration that refuses moderation, a runaway motive that grows with the stretching distance, turning galaxies to orphaned stars, stars to orphaned planets, and atoms to orphan nothing. The very notion feels like myth rewritten as equation, and yet a tiny lean in a parameter is all it would take. Between these doors, a subtler possibility lurks, one not quite an ending but a change of script, a vacuum that is not the lowest it can be, and a bubble that one day decides to grow. Such a decay would rewrite the constants we call fundamental, rolling the cosmic fields into a new minimum, where chemistry is a stranger, and light moves with a different accent. If that bubble is on its way already, we would never feel its approach, and that too is a kind of ending you can only imagine. Tonight, we set our compass by these three doors and the shadow option beyond them, and let history, theory, and the faintest conspiracies of anomalies guide the hand that points. We will drift across star lifetimes and black hole whispers, march backward with Einstein, Friedman, and the pioneers who tried to weigh the sky, and wade into the delicate marsh where data meets ideology. Somewhere in there, the last day already exists as a probability, and the question is whether we can hear its footfall earlier than we think. Consider the slow world first, the heat-death valley, where the end is not a moment, but a gradient approaching zero, a color that fades so gradually you do not notice it is gone until you reach for it. In this scheme, expansion continues forever, but not with the violence of a tear, rather with a relaxation that turns the cosmos into isolated pockets and eventually into horizon islands alone with their whispers. The timeline is vast here, a carpet rolled out longer than ordinal metaphors can reach, and yet we can stitch its panels with cautious thread. Stars burn because gravity makes them hot, and they stop when their fuel is gone. And both of those facts are simple and inexorable when given enough time. Massive stars leave black holes as punctuation marks, while modest ones end as white dwarfs cooling toward invisibility, and the smallest red dwarfs smolder for trillions of years, the last campfires on a plain that once blazed. As star formation dwindles with the dwindling gas, a million Milky Ways hush into a catalog of embers. Around a quadrillion years from now, if the arithmetic of galaxies remains untroubled, the stellar era gives way to the degenerate era, where the torch passes to remnants and chance. White dwarfs, neutron stars, and brown dwarfs dominate the population, as collisions and slow orbital dances rearrange them in manners too patient for human stories. If protons decay is speculation, many grand unified theories suggest, though experiments have not caught them in the act, the very matter of these remnants eventually unravels. Proton decay, if it happens, might erase what stars leave behind, drip by drip, like sand undermining a castle, after the tide has retreated, the half-lives measured in numbers that make calendars blush. Without proton decay, white dwarfs and neutron stars persist and cool, mass rearranging into black holes, or sometimes ejected as loners in the night, fate decided by interactions that take longer than languages last. The degenerate era is not static. It just moves like glaciers compared to lightning. Black holes, the punctuation marks, evolve too, not by swallowing alone, but by leaking, their event horizons gently glowing with Hawking radiation, a quantum trick that turns nothing into something at the edge. A stellar black hole takes an unimaginable time to evaporate, a number with more zeros than a human book can comfortably print, while the biggest supermassive black holes could persist for up to 10,100 years before sighing their last photon. Along the way, they might capture, digest, or be left alone, depending on the local emptiness. As the black holes fade, there is a last sterility to overcome. When no gradients remain, nothing can happen in the usual sense, and yet statistical mechanics whispers a different subtlety. In a thermal bath, rare fluctuations can visit islands of order, tiny eddies in an ocean of sameness, and with enough patience, Even brains could flicker into being, complete with memories no one gave them. These Boltzmann brains challenge the idea of typicality, poisoning the notion that we are ordinary observers in a heat haze. If the universe ends that way, it invites a kind of solipsism backed by probability, where the most common observers are disembodied thoughts, dreaming of laws they never saw applied. And that is a disturbing implication for any theory of endings. One response is to require a finite thermal future, perhaps by letting the vacuum decay or the universe crunch, so fluctuation brains do not outnumber early biological ones. Another is that a de Sitter horizon limits the accessible entropy, and therefore the problem, though arguments tread on deep speculative ground. The arrow of time is entangled in this, because heat death anticipates a direction, a present that leads to a future with more entropy and no cyclic exception to unwind it. Why the early universe had such low entropy remains one of the heaviest questions, like a domino set carefully on a pedestal before the fall. Penrose has suggested that the beginning is a constraint on the curvature, a special geometry that refuses the wrinkled chaos of generic initial states, and he ties that specialness to a possible end that softens. In a heat-death scenario with a true cosmological constant, the universe approaches a de Sitter state with a fixed horizon and a characteristic temperature, a tepid glow bleeding from emptiness itself. That horizon has a thermodynamic entropy, an enormous number around which Poincare recurrence times become absurdly vast, so vast they dissolve the meaning of prediction in a fog of unreachable timescales. Whether that entropy is the right ledger to count is a debate that lives at the edge of our rituals and axioms. Meanwhile, obscure proposals drift into the stillness like leaves, each claiming to ease the paradox with a different breeze. There are whispers of holography, in which the physics of a volume is described by information on a boundary, perhaps the cosmic horizon itself, encoding the story of the interior in a code we barely understand. In that view, heat death is a limit of compression rather than a simple dilution, and the last state is as much about geometry as it is about temperature. Between such abstractions lie playful speculations, like white dwarfs turning into black dwarf supernova after unimaginable ages through quantum tunneling, as if the last fireworks found a way to surprise us. The numbers assigned to such events are grotesquely large years, written as towers of exponents, and yet, in the slow world, grotesque numbers are a form of honesty. Even the notion that dark matter particles can decay could nudge the ledger differently, adding faint threads of radiation to a tapestry already thin. What, then, becomes of memory and information in the heat-death valley if black holes evaporate and the universe smooths into uniformity? The black hole information puzzle hints that unitarity might save everything, that the final radiation carries the fingerprints of what fell in, scrambled but not erased. If so, the last state of the universe could be a vast library written in a script only the horizon understands, and the idea of loss becomes a subtler, more ambiguous experience. Data and theory meet awkwardly here, with Planck maps of the cosmic microwave background tracing the early conditions beautifully, while telling us little of the far future beyond the sign of the acceleration. Low-frequency radio surveys and 21-centimeter experiments will sketch the neutral hydrogen story, while lensing maps weigh the invisible scaffolding with more nuance, and still the crucial decimal in the dark energy equation of state hovers under debate. Every improvement shrinks possibility space, but leaves room for a surprise. If one wants conspiracies, they arrive quietly as anomalies, like alignments in the CMB quadrupole and octopole, often called an axis, or a cold spot that teases non-Gaussian dreams, and none of them definitive. These are either random flukes amplified by the human eye, or hints of a story in which boundaries and cycles play a role beyond our textbooks, and their ambiguity keeps them interesting. The slow world does not forbid intrigue. It only demands patience while intrigue ages. In the heat-death veil, patience is the only luxury, and the cosmos seems intent on exercising it until numbers lose character and boundaries blur. Yet even here, a single parameter could change, a vacuum could slip, and everything about the end could rewrite itself in a fine print no one noticed. The gentle hush becomes provisional, because deep under the quiet, the vacuum itself may not be as settled as it appears. If the slow hush is a sky without endings, the heavy alternative is a sky that closes its wings, a return to density where the fabric folds under its own weight, and the big crunch plays like a coda that rhymes with the overture. For this to happen, gravity must outfox expansion, or dark energy must relent and switch sign, turning a gentle push into a pull that grows with scale. The math knows how to do it. The question is whether the universe remembers how to listen. In the early 20th century, Einstein's first model of the cosmos was static and closed, balanced by a cosmological constant added like a thumb on the scale to keep it from collapsing. It was a delicate equilibrium, and Friedman and Lemaître showed that dynamic universes were not only allowed, but natural, with expansion and contraction as live options. Einstein's thumb was later interpreted not as a mistake, but as a name waiting for a story, and that story became the present acceleration. Closed universes and their big crunch, destinies require enough matter-energy density to curve space back onto itself, like the surface of a sphere, geodesics closing in the darkness. Observations of the cosmic microwave background suggest extraordinary flatness, with curvature constrained so tightly that any closure is slight, but flatness does not guarantee acceleration forever. If dark energy is not a cosmological constant, but a field that can roll, a state that can change, it could trade its push for a tug. Cyclic universes are older than physics, which gives them a certain echo, like the sensation of déjà vu when a new theory resembles a folktale. In modern garb, cycles can be arranged through brain cosmologies, where our universe is a membrane colliding with another in higher dimensional space, or through ekpyrotic slow contraction that smooths and flattens before bouncing. These models are crafted to launder entropy, to reset the mess that each cycle would otherwise accumulate. And the laundering is where the cleverness hides. Entropy is the enemy of clean cycles, because each loop wants to leave behind a little more disorder, and eventually the loops would lose their rhythm, flattening into heat death anyway. The ekpyrotic idea proposes a solution. During a slow, ultra-smooth contraction, anisotropies are ironed out and entropy is dumped into degrees of freedom that do not grow from cycle to cycle, like an account hidden from the main ledger. Whether the dumping is physical or a trick depends on which assumptions one is willing to keep. Loop quantum cosmology provides another escape hatch, replacing the singularity with a bounce crafted by quantum gravity effects, a pressure from the discreteness of space that resists collapse at the last moment. In such pictures, a previous universe contracts, heats, and then tunnels or rebounds into expansion. A bounce an instant where classical geometry fails and a new classical phase emerges from the phone. If this is the case, the beginning we call the Big Bang is merely a bridge, and memory could seep across in subtle ways. Penrose's conformal cyclic cosmology plays a more audacious game, suggesting that the end of a universe in a de Sitter heat death can be reinterpreted as the beginning of the next by rescaling the geometry, discarding masses, and letting only shapes survive. In this view, black holes evaporate, mass fades, and conformal time becomes a way to stitch dead universes into newborn ones. Circles in the CMB, perhaps recording encounters between the heavy ghosts of the previous eon. Evidence for such circles is contested, but the ambition of the idea leaves an imprint of its own. If acceleration is the current fact, how could a crunch still lurk ahead? One answer is that dark energy is a chameleon, an evolving field whose equation of state crosses the phantom divide and then climbs, a dynamic that could eventually become negative and antimorphic. Another possibility is modified gravity, where the rules of curvature deviate on cosmological scales in ways that salvage contraction without offending local tests, a delicate dance that theorists choreograph and data judges. Observationally, any approach to a big crunch would announce itself through a slowing of the acceleration in far-flung supernova, a pattern in baryon acoustic oscillations, and shifts in the growth of structure seen through weak lensing maps. But the timelines are long. Current data prefers a constant or nearly constant dark energy, but small deviations are not closed off, leaving a sliver for a future retraction. Within that sliver, stories about reversals live, waiting for a small tension to metastasize into a trend. There are curiosities in the sky that some treat as hints and others as noise, like the large angle anomalies or the alignment of low multipoles in the microwave background, as though a preferred axis peeks through symmetry's curtains. A closing universe might inscribe such alignments, though other explanations exist, from foregrounds to chance, and the discipline is careful not to lean on intrigue without anchor. Yet the presence of such whispers reminds us that the sky sometimes sketches outside the lines we draw. A crunch requires that the matter-energy budget is not forever dominated by a constant vacuum, and that's where the wriggle room lies, in quintessence fields that roll, potentials with features, or interactions between dark sectors that mimic constants imperfectly. In those models, the effective pressure can change sign, and the universe, like a tide that turned unnoticed, could begin to decelerate and eventually contract, horizons reversing their growth. The timescales might dwarf human patience, but the signature would swell from the noise one day. If contraction came, the lights would brighten in reverse as density increases, structure formation accelerating into a more violent phase, collisions becoming common, radiation blue shifting back towards substantive influence. The future night could end in a flash of everywhere heat, perhaps regularized by new physics at the bounce point, where quantum gravity takes over and prevents infinite crush. Whether that flash is fatal or fertile depends on how the theory shepherds fields across the divide. And there rests a philosophical hook. If we are embedded in a cycle, how much of our present owes its fingerprints to the previous loop? And could we ever measure ancestral scars? Penrose's circles are one candidate, while others point to non-Gaussian features, gravitational wave backgrounds, or relics in neutrino distributions that might retain a rhythm incompatible with a one-shot beginning. If the crunch is not merely a death, but a contraction with a plan, the plan might leave a watermark. Conspiracies of pattern and prophecy find easy food here, given how old myths spoke of returning ages and sutured time, but the reality is more demanding than metaphor. The equations must unwind across the dangerous space near the bounce, avoiding infinities and preserving coherence, a task that tests every toy model with a gauntlet of consistency. The big crunch is not merely gravitational nostalgia. It is a technical cliff that tempts the brave with a promise they may or may not keep. The choice between hush and crush remains intimately tied to dark energy's character, a character we still write as a single parameter in our fits, knowing that such reduction may be hiding a script with an ensemble cast. Even the Hubble constant tension, our disagreement over how fast the universe expands today, teases at physics beyond the standard model, which could shift the extrapolation toward or away from futures we think we know. In the gap between what we measure and what we trust, endings adjust their posture. In this crossroads, the big crunch is neither favored nor buried, and its mathematics remain an invitation to test the limits of cycles, bounces, and entropy management. Lurking behind the technicalities is an aesthetic pull, a sense of symmetry that would be satisfied by a universe that returns, even if it returns revised. But somewhere beyond aesthetics, another option waits, less symmetric, more alarming, a rip that is not patient with structures we took for granted. Imagine the calm night cracking not with sound, but with subtraction, as bonds that once held with quiet confidence start to loosen, not because the parts quarreled, but because space itself insisted. The big rip outlines this scenario with an equation of state parameter below -1, a pressure so negative that the energy density of the vacuum increases as the universe expands, feeding acceleration instead of attenuating it. This feedback is gentle now, but if sustained, it grows impatient. In a rip world, there is a schedule of unbinding. Each step closer to the end, a loss of cohesion at a larger scale, then a smaller one, as though the universe were peeling layer by layer. First, galaxy clusters lose their gravitational glue, the feeble long-distance grip surrendering as expansion overwhelms mutual pull. Then galaxies dissolve, stars departing as orphans into a background that stretches faster than they can respond. Later, planetary systems unbind, tides from the expanding metric outpacing the sun's hold. The calendar continues down, if the phantom pressure persists, to molecules and atoms, where the electromagnetic forces that usually ignore cosmic expansion suddenly notice the tensile drift and fail to keep electrons leashed. Even nuclei would not be safe in the final instance, as the rip acts like a strain that increases without limit, prying apart what only the strong force holds. All of this would be timed by the exact value of the equation of state parameter, with small differences in that number deciding whether the end is tens of billions of years away or sooner. Observationally, we hold W near -1 within a few percent, with W less than -1 not excluded, but not demanded either. An ambiguity that keeps the rip in a drawer marked unlikely, but not impossible. Measurements from supernova, baryon acoustic oscillations, the cosmic microwave background, and gravitational lensing all triangulate the pressure. Yet systematic uncertainties whisper that we have not yet exhausted surprise. If W slips below -1 and stays, the clock starts, even if the hands are slow. Theoretically, phantom energy behaves badly in simple field theories, allowing negative kinetic energies and unstable vacua, which makes it less comfortable as a fundamental ingredient. Modified gravity offers a way to mimic W less than -1 without ghosts, by bending the rules of spacetime on large scales in ways that hide in the weeds of general relativity's precision locally. In these constructions, a rip-like future can arise as an emergent phenomenon, not a raw pathology. Another cousin of the rip is the sudden singularity or little rip, where the acceleration grows without bound, but only asymptotically tears, avoiding a final moment of infinite stretch, while still disrupting structures along the way. The cosmos would tend toward deconstruction, without a single flag marking the end, a drip of disintegration rather than a crack. Such timelines, like the Big Rip itself, are labeled by behavior at infinity, and our instruments glimpse their hints only through faint deviations today. In this family of ends, cosmic horizons creep inward as the acceleration intensifies, isolating each observer more and more, like islands whose shorelines recede from the charts. Information trapped beyond the horizon is not recoverable, and the thermal bath associated with the horizon looks hotter as the horizon tightens, an oddity of perception rather than a warming in the usual sense. If you could engineer a beacon for the far future, the shrinking light cone would make your generosity futile. There is an almost conspiratorial allure to imagining that the equation of state parameter is masquerading near -1 today, hiding its phantom nature until better instruments catch it unprepared. Some model builders draw potentials designed to linger near the cosmological constant before diving, as if the field practiced suspense, biding time until the rip becomes inevitable. Skeptics point out that nature rarely cares for drama, but drama has a way of reappearing when parameters wobble within errors. Layered into this, a separate blade could fall first, a false vacuum decay, where the Higgs field or some other scalar, trapped in a metastable condition, tunnels to a lower energy state, nucleating a bubble that expands nearly at light speed. Inside that bubble, the constants of nature can change, masses and couplings rewrite, and chemistry loses its identity, while outside, the old rules still apply for the fleeting time left. If such a bubble arrives, it overrides whatever schedule the rip kept, an emergency exit that is anything but safe. The standard model, with measured top quark and Higgs masses, suggests metastability is possible, but the lifetime is fantastically longer than the current age. a comfort that is statistical rather than existential. Yet metastability is a reminder that the vacuum is not a passive backdrop, but a field with a potential and history. And cosmic endings can be as much about field theory landscapes as they are about geometry. A bubble could be indifferent to dreams of hush, crunch, or rip proceeding on its own logic. Even without catastrophes, the deepening acceleration changes the texture of communication, ensuring that distant galaxies become not merely dim but unreachable, a fact with philosophical gravity. We live at a time when the cosmic web is still a connected graph for practical purposes, but in the far future of an accelerating universe, observers will see a lonely island of bound matter, surrounded by blackness that hides the history we take for granted. Perhaps messages can be carved into local structures, but cosmic archaeology will be parochial. The rip, if it were to come, would challenge the idea that fundamental structures are immune to cosmic tides, a notion that rests on the scale separation between atomic forces and cosmological expansion. If the expansion is acceleration with a pace that overwhelms even bound systems, that separation collapses and the hierarchy of stability burns away, layer by layer. This collapse would be the most dramatic rewriting of assumptions we possess, a revelation not of new particles, but of limits on coherence itself. Data will arbitrate this quietly, not with headlines, but with small curves bending in deeper surveys, with future telescopes mapping the expansion history at redshifts where today we squint. The promise of high-precision cosmology lies in these gentle deviations, the curvature of a graph that hints at tomorrow's bonds, a drift in W that chooses patience, return, or rupture. Each more precise measurement tightens the net around whichever law the vacuum follows, and the vacuum does not negotiate. If there is a message to be found about endings, it is not a line of text, but a spectrum, encoded in gravitational waves from the earliest moments, in the statistics of primordial fluctuations, or in the harmonics of the cosmic neutrino background. Some speculate that deep surveys of supermassive black hole mergers might reveal echoes, subtle modulations that hint at the horizon's microstructure, and thereby at the deep vacuum's rules. In the rip's shadow, such clues matter, because the only preparation is understanding. The rip is not favored by caution, but it remains a moral to a proverb about taking parameters seriously, a boundary condition for our imaginations that keeps us honest about what W can do. It is a mathematical reminder that the cosmos can end not only by exhausting its gradients or collapsing under its weight, but by a runaway in the equation we currently treat as a placeholder. If the placeholder turns out to be a personality, the future will unfold in an accent we must learn quickly. 3 doors remain ajar in the mind now: the hush of entropy's hymn, the fold of a universe returning, and the tear of a vacuum that refuses restraint, each one an ending that changes the word ending. The path we walk between them is lit by instruments and escorted by myths, because even data needs a narrative to enter our sleep, and the oldest narratives welcomed returns and burnings and long winters alike. To imagine the end is to imagine what we value about beginnings, and both are mirrors to each other's questions. Our species has always negotiated with time, building cathedrals that outlast lives and algorithms that shrink seconds, always pretending that clocks are tools rather than rulers. In the face of the cosmos's endings, clocks become metaphors, and we ask whether any form of thought can ride entropy's slope forever, or find a loophole in physics that keeps questions alive. The answers depend as much on ingenuity as on the universe's hospitality to persistence. Physical eschatology, the sober cousin of prophecy, measures these possibilities with integrals and inequalities, approximating futures the way sailors chart currents. Freeman Dyson imagined eternal intelligences stretching finite energy over infinite time by slowing their thoughts, spacing out computation so that each heartbeat is rarer but never ceases, a scheme that depends critically on how temperatures fall. If heat death arrives with a true constant vacuum, horizons impose a floor to the temperature and a ceiling to the entropy within reach. and Dyson's dream faces constraints. Landauer taught that erasing information costs energy, so perhaps reversible computing could minimize thermodynamic expenditure, letting minds persist on thinner and thinner diets, a technical grace that feels like monasticism for algorithms. But the heat baths of the future and the scarcity of free energy place hard limits, and even reversible steps require clocks and control, which are not free in a cold universe. The physics of memory meets the sociology of persistence here, an unlikely conference in the shadows of time. If the universe leans instead toward a crunch or a bounce, then strategies change, because an ending becomes an event rather than an asymptote, and timing matters more than thrift. A civilization that anticipates a crunch might try to inscribe messages in long-lived modes, neutrinos, gravitational waves, topological defects, hoping that a bounce carries patterns forward across the quantum foam. Whether such signatures survive depends on the true microscopic rules of spacetime and the generosity of the transition. Penrose's conformal cycles suggest that some structures scale across eons, and he has pointed to concentric circles in the microwave background as possible fingerprints of black hole encounters in a previous round. Critics have challenged this claim with simulations and statistics, leaving the question open but tilted toward skepticism. Yet the idea itself repositions hope. Perhaps endings encode more than we suspect. A faint entropic inheritance across ages would be a kind of cosmic genealogy, restless and oblique. The rip world allows the fewest strategies. When bonds fail sequentially, messages must be local and ephemeral, and trust is placed in the brief windows that precede each unbinding. In such a world, preparation is less about longevity and more about savor, a philosophy as much as a plan, because the scale by which we measure permanence shrinks without apology. The end becomes not an enduring monument, but a gentle audit of what mattered while bonds held. Some speak softly of cosmic engineering as a defiance of endings, contemplating star lifting to harvest mass for fuel, black hole farming to extract energy from spin and accretion, and even stellar rearrangement to optimize habitats in a lonely future. Cluster-scale schemes imagine shepherding galaxies into bound structures before expansion isolates them, a cosmic Noah's Ark built with gravity and patience. The building blocks seem fantastical, but their principles are ordinary. Use what remains abundant and accept the costs of scale. These thought experiments underline a truth that is easy to miss. Endings are not solely about physics, but about agency within physics, about what choices become thinkable as eras change. The physics sets the menu. Intelligence interprets the cuisine, and the tools we forge today teach us how to imagine tools appropriate for nights we will not see. Our own moment might be early for such audacity, and perhaps that is why dreams reach so naturally toward it. Beyond plans lies a quiet humility. No matter the ending, the universe will have been a cascade of transformations that allowed islands of awareness to sketch themselves in dust. Whether the final page is blank, folded into a new chapter, or torn out, the act of turning pages has already occurred, and its evidence is in the way you feel the night. The end is not obliged to summarize. It can simply be while we learn to be inside it. There is also the subtle conspiracy of coincidence, the way fundamental constants conspire to allow chemistry, stars, and curiosity, an arrangement often filed under anthropic reasoning or fine-tuning debates. If there are many universes with many constants, we are not surprised to find ourselves in one that allows stories, and that reduces awe without erasing it. If there are few, the precision is a puzzle without a bracket. The fate of the universe echoes these questions, because different fates are invited by different constants, and perhaps this is not an accident, but a census of possible skies. The Hubble tension, the discord between early and late-time measurements of expansion, is a current crack where new physics might appear with a whisper, changing how quickly distances open. If this tension resolves into an evolving dark energy or a modified gravity, the door to one ending will lean on its hinges differently, and the curve of the future will adjust. This is how endings become empirical, not by pronouncement, but by slight corrections in the slope of a line. Ultimately, the most relaxing thought in a universe of sharp possibilities is that endings are not punishments, but boundary conditions on meaning, and meaning has always adapted to boundaries. Whether we are heading toward the fading cradle of heat death, the return journey of a big crunch and bounce, or the unruly denouement of a big rip, the night remains an invitation to imagine with care. The imagination does not alter the ending, but it enriches the way we arrive. If you listen closely to the sky tonight, you can hear a softness that belongs to no single future, a texture shared by all endings, the insistence that curiosity is worthwhile even when the last page is unwritten. The more precisely we trace dark energy, the more honestly we can measure entropy, and the more courageously we can test cyclical or tearing destinies, the closer we come to understanding what it means to end. Understanding, far from erasing wonder, deepens it until sleep and thought are the same. Before you drift into sleep, remember mystery is never truly lost, only waiting to be found. If you enjoyed this journey, subscribe for more relaxing ancient mysteries, and let your curiosity guide you deeper.